Today we will be solving leetcode 1601, that is maximum number of achievable transfer requests. In this question we are given n buildings and each building has a number of employees, and this is a transfer season where some employee wants to change their building. So we are also provided with a request array which consists of values like from and to, where from represents the building that the employee is leaving and to represents the building to which the employee wants to transfer. So we have to return the maximum number of achievable transfer requests. But the case is that all the buildings are full. So the list of requests is achievable only if the net change in employee transfer is 0. So by net change, we are referring to the number of employees leaving should be equivalent to the number of employees moving in. So if I'm saying there are five employees in building 1 and 5 employees in building 2, so if a transfer is taking place in between these two buildings, so after that transfer the number of employees should be equal. There should not be any change in the number of employees. So how we can solve this question? Let's try to understand using this example. So in this example we are given 5 buildings and 6 requests, and we are asked to return the maximum number of requests. Now what we can do, so the brute force approach can be, firstly we will create all the combinations of request. Then what we can do, we can calculate the net change for all those combinations, and after that we will return the maximum request with which we achieve that net change. We know that the maximum number of requests will always be equivalent to the total number of requests, because if all the requests are accepted and the net change is also 0, then we can say that it is the maximum number of requests. So what we are going to do, we are going to check from the total number of requests. So like we will be checking from the maximum number of requests to the minimum number of requests, and as soon as we get the answer we will return it. So what I'm trying to say, I'm saying let's try to check with r equals to 6, where r is the number of requests that we are going to accept, and we will see what will be the net change. Now for r equals to 6, what will be the possible combinations? Combination will be 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, right? From 0 to 5 I am considering. So this will be the combination because we are considering all the requests, right? Requests are 6 and our R is also 6. So there will be only one combination. This will be the combination. So let's try to check the status in the building when we are going to accept all these requests. So this is our array which will be checking our status of the buildings or the net change. Now I am saying check for the first combination. Check for the first request. So first request is this 0, 1. Let me change this color so it will be more understandable. So if I am saying 0, 1 is the first case, so in 0, 1 what is happening? Employee is leaving 0 building and going to building 1. So this will be the change. We are going to add 1 at first index and going to subtract 1 at 0th index. Then go to second request. Second request is leaving first building and going to building 0. Then third request is leaving 0 building and going to building 1 again. Then fourth request is like I'm going in this order. This is the combination. This is the index. So these will be the index. Now I am saying I was at fourth request, right? So fourth request is what? Fourth request is 1, 2. So leaving first building and going to second building. So this will be +1. Then fifth request is leaving second building, going to 0 building. This will be +1. And the last request is leaving third building and going to the fourth one. Okay, so what will be the final status of our array? It will be somewhat like this. It will be 0. When I am going to add up this whole thing, this is also 0, this is also 0, and this is -1 and +1. This is the status after the first combination. And we can see that the net change is not equivalent to 0 because at these two indexes values are -1 and +1. So we didn't get the condition applied. So we were not able to achieve the condition when the maximum request is equivalent to 6, and the combination also wasn't able to achieve that condition. So now what we are going to do, we are going to check for r equals to 5. When r is going to be 5, we know that the requests are 6. So how many combinations are going to be created? According to that, there will be 6 combinations. And in all those 6 cases, what is going to happen? We are going to leave one of the request every time. So like for first one, if I am saying there will be 0, 1, 2, 3, 4, then next combination will be 1, 2, 3, 4, 5, and so on. Like these will be the combinations. So in this manner we will be creating all the combinations, and then we will be checking for all of them. So let's try to do for any one of them. So let's try to take this first one and we will analyze this. So I'm saying when r equals to 5 and for combination 0, 1, 2, 3, 4, let's try to check the status of our building after all these request acceptance. So I'm saying firstly check for 0 request. So this is the 0 request. What it is? -1 +1. Then check for first request. First request is leaving first building and going to 0 building. Then check for second request. This is the second request. Leaving 0 building, going to first building. Then check for fourth request. Leaving for first building, going to second building. Then fifth request, leaving second building, going to first 0th building. And last request we are not going to consider because it is not in our set. Our set is having only 1, 2, 3, 4. So we did for 0, 1, 2, 3 and 4. So after these set, what is the status of our building array? What is the status of our building after accepting this set of requests? So here it is 0, here it is 0, here it is 0, here it is 0, here it is 0. So for k equals to 5, so for r equals to 5, with this set, we are able to achieve the net change equals to 0. Right? This condition is satisfied. Now if we are going to check this set in this diagram, we can clearly see that our set is not including the fifth request, that is 3 and 4. And in this diagram we can see this case is not possible, where employee is leaving building 3 and there is no other employee getting in or moving in this building. So this transaction is not possible. And also from building 4 there is not even a single employee who is moving out. So we can clearly see that our approach is. So now let's try to code this solution. This is the algorithm that we will be using, where firstly we will be checking for the maximum number of achievable requests. Then what we will do, we will check for all the possible combinations. Then we will create a building status array as we already saw in the dry run. And we will be updating that array for all the transactions. And at the end of all the transactions, we will check if the net change is 0, then we will return k. Else what we will do, we will again go and reduce our k number of requests, and then we will try to do the same thing. So let's try to write the code. So I'm saying for k in range will be length of request, length of request 0, but in reverse order, because we are going to check for the maximum one first. Then create all the possible combinations, right, with k. And I'm saying let's create a building status array which will be initialized with 0. Now check for all the transactions. We will be subtracting this one and doing the addition for the one in which the employee is moving. So this will be +1. And after these transactions, what we have to check? We have to check if there is any change in the building status or the net change is 0. If there is no change in the status of the building, then what we have to do? We have to return k. And at last, just add a return statement as return 0. So that if there is no answer, we will return 0. We can see this code works and it is quite efficient. So I hope this video was helpful, and if you find this video helpful, then you can like this video, subscribe my channel, because I am going to share some more videos on data structures and algorithms, so you will be notified, and I will soon come up with some more questions. Thanks for watching.